This is our video on geometry. So we're going to just cover some things in geometry. We're going to focus mainly this term on surface area and volume, but I'd like to do a quick introduction for those of you who might not have taken math recently into what some other terms mean. Okay, so I'm going to be using this GED formula sheet that I've given you quite a bit today, so you might keep track on here. The first thing we're going to talk about is what perimeter means. So you'll want to put this in your notes under the word geometry. So in your notebook, under the word geometry. Perimeter is the distance around an object. And in order to find perimeter, what you do is you add all the sides. Okay. So if I have a triangle that I want to find the perimeter of, and one side is 2 centimeters, one side's 3 centimeters, and one side's 4 centimeters, I simply add them up, 2 plus 3 plus 4, to get 9 centimeters as my perimeter. Okay. Formulas for perimeter that are more specific are found on your formula sheet right in this area here. So you certainly can use those, but remember, perimeter is just when you add all of the sides together. Okay. Now, when you're dealing with circles, you have a special word for perimeter, and the distance around a circle is called the circumference. Okay. And we have a special formula for the distance around a circle that's either 2 times pi times r or 2 pi times d. So we've talked about pi before, and we've talked that pi equals 3.14, and that's an estimate. Or that pi exactly is 22 over 7. Okay. So when we're working with pi, you can use one of those two numbers to represent it. Make sure you show your work so that I can know which one you used. Okay. The other pieces for circumference are you have to know what the radius and the diameter are. So the radius is the distance from the center of the circle to the outside of the circle. The diameter is the distance through the center of the circle across this entire circle. So when we're looking at radius and diameter, the radius is half of the diameter, or the diameter is twice the radius. Okay, so you can see that's a radius and that's a radius, so together they're the diameter. So in order to use these equations for the circle, for circumference, if we have a circle that has a radius of 3 centimeters, we would do 2 times pi times 3. Okay. So you'd then go ahead and do 2 times 3 is 6, and 6 times pi being 3.14, you'd come up with 18.84. Okay, so that would be the circumference of the circle, and that would just be in centimeters. Again, this should be a review for you. You should have heard this somewhere else at some point. Okay, now we're going to talk about area a little. So area is let's see, how would I say it? It's the length times the width of a rectangle. So if I draw a rectangle here, the area is talking about how much space that covers. Okay, so practical applications of this are if I'm going to put grass seed around my yard, or also if I'm going to paint my wall, I might need to know how much space I need to cover. So we could say area is the space covered by a shape. Okay. So we have different formulas for area depending on what it is. For a rectangle, area equals length times width. So you multiply one side by the other side. So 3 times 3 is 9. And since we're dealing with we're essentially dividing up my rectangle into squares, we use square units, meaning we multiply these two units together. Centimeters times centimeters is centimeters squared. Okay, each of these is a square centimeter. That's different than just a centimeter. So area always has units squared. Okay. Your formula sheet gives you areas for other types of objects, such as a square, a rectangle, parallelogram, triangle. The only other one I'm going to touch on is the circle. So if we have a circle here, and I'm finding the area of it, I need my radius. So let's say my radius is 6 centimeters. I'd take my formula from my sheet, area equals pi r squared. So what I'm actually finding is how much space is inside of here. And I'd plug this in, area equals pi times 6 squared. So 6 squared is 36 times 3.14. And I'm going to let you do the math on that one. Okay, no calculators. You don't need a calculator for that. Okay, so we're going to move on to the new information today. And the new information is that of volume and surface area. So volume talks about how much space something takes up. And we've been doing a lot of volume measurements in the lab. We've been measuring volume in milliliters, but we also have been measuring volume in centimeters cubed if you think about the density. Okay, we said that milliliters and centimeters cubed are the same thing. So a cubed measurement can also be a way to measure volume besides milliliters. So what we're looking at is we're looking at how much space does an object take up. So we're looking at, if I filled this, how much stuff would I have to put inside of there? Okay. So we could fill it with water and then measure the milliliters, but we can also calculate it if we know the measurements. Okay. So that's what we're going to look at today. And if we look on our formula sheet, we'll see that here are my different formulas for volume for different shapes. So let me just walk you through these shapes and what they are. So first is a rectangular prism. So this is an example of a rectangular prism. Okay, it's rectangular. It's basically a box. A right prism is very similar to this one, meaning that it has a base that has right angles. Okay. For example, we could do that with this triangle. Okay. The next one is a cylinder. Cylinder, think of it as an oatmeal container. So this is a cylinder. Okay. As is this one right here. This one's a bigger cylinder. The next one we have a measurement for is a cone. I'm sorry, an equation for. A cone, think of an ice cream cone. Okay, that's a cone. And then the very last one is a sphere. So if I have something that looks like a globe or a ball, that's what I'm talking about with a sphere. And I forgot, oh, did I do a pyramid? Pyramid, I showed you this one, right? Okay. So I think I've covered all my shapes now. So first thing you have to do is decide which shape you need to do. Okay. So let's look at the formula sheet here. And let's look at what it says for, I'm getting it focused right now for you. So if I look at my formula sheet, it's not focusing for me, so I'll write it down here. So it says volume equals length times width times height for the rectangular prism. So that means for this rectangular prism, I would measure my length, my width, and my height. Okay, 3 dimensions, and I would multiply them together. For my right prism, volume equals capital B times H. So what we mean by that is, let me find the right prism. So if we're looking at the base here, we would find the area of the base. So this big B means area of the base. Okay. So if I found the area of this base and then the height, that would give me the measurement that I need. So that is if it has right, if it's a right prism, meaning it has right angles. Okay. The next one is for the cylinder. So volume of a cylinder equals 1/3 area of the base times the height. So remember that big B means area of the base. Oh, that's for pyramid. I'm sorry. Let's go back. So this one's for pyramid. I'll do cylinder in just a minute. Okay. So if we have 1/3 area of the base times the height, so for my pyramid, here we go. So I have my base, so I would calculate how much this base is. So this length times this length times the height. So the height would be from the bottom to the top here, if I stuck my pen through there. And then times 1/3, or you could also see it divided by 3. So this is equal to area of the base times the height divided by 3. Either one of those works. So that's for the pyramid. Okay. Let's take a look at the cylinder, which I skipped over, and also a different right prism. So here's another right prism. Okay. Remember, for a right prism, we have volume equals the area of the base times the height. So the area of the base, it's the shape of a triangle, right? So I'd have to go and look up the area of a triangle from my formula sheet. So if I go to area of a triangle, it says 1/2 base times height. Okay, so I'd have to measure the base of the triangle and the height of the triangle, and then take 1/2 of it to get that capital B there. Times the height, so how tall is it? If I see this side, then I can calculate that height. Okay, so that's how I would go about doing this one. I would take the area of the base, so measure this one, measure this one, divide it by 2, and then I'd do it times the height. Let's look at the cylinder next. So this is for a cylinder. So area of a cylinder, the formula they give us is volume equals pi r squared h. Now if you look before at the area of a circle, you'll notice that pi r squared is the area of a circle, right? So that's having you find the area of this base and then multiply it by the height of the cylinder. Okay. The next one's the cone. So let's look at a cone. So my cone, the formula for the cone, volume equals 1/3 pi r squared h. Okay, so basically I'm going to take my radius. So you're going to take the radius of the circle, So from here to the outside, from the middle to the outside, squared times pi times the height. Again, the height is if I stick my marker down through there. That's the height that I'm talking about. And then times 1/3, or I can see that as divided by 3. Okay, the last one I have for you is a sphere. So here's my sphere. Okay. And the formula from our formula sheet for a sphere is 4/3. Excuse me a second, I have a new marker. Four over 3 pi r cubed. Okay, so what that means is that you find the radius of it. So the radius would be from the center to one side. You take that to the times itself 3 times. Then you multiply it by pi, and you multiply it by 4/3. Okay. So this is something that you're going to have to play around with a little. Okay. The next thing we're going to look at is surface area. So basically, surface area is if I had to paint the outside of a figure, how much would it be? So basically, surface area is the area of all of the sides added together. So for this one, you would find the area of the triangle on one side, the area of the triangle on the other side, the area of the triangle on the other side, and then the bottom. We do have formulas for these things from this formula sheet. So let me just walk you through what some of these symbols mean. So with rectangular prism, it has you do 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. Okay, so W is width, L is length, and H is height. And you substitute those values in there. Personally, sometimes I think it's easier just to think about surface area being each side and that I'm adding them together. Okay, now when we take the right prism, okay, let me take you with that formula and take you through that. So with a right prism, if I'm looking at the surface area, so here's my right prism, meaning it has the sides that are rectangular or square and a different shape on the ends. So the equation they give us is pH plus 2 times B. Okay, B again is the area of the base. So the area of the base here would be the area of this triangle. Okay, and what we're looking at is this area and then the other cap on the other side, right? So we're looking at the area of these two right here. Then what they're having you do is take the perimeter, and this P means perimeter of the base. So you're going to take the perimeter of the base. So the base is the side that is not like the others. In this case, you take the perimeter, you'd add up these 3 sides of that base times the height. So to find the other one, what you're doing is you're taking each of these sides, timesing it times the height, and then adding the 2 sides on. Okay. The one for the cylinder, the pieces that you need to know. So this is cylinder. Surface area equals 2 pi RH plus 2 pi r squared. So you need to know the radius. So with a cylinder, you have to find what the radius is. So from the center to the outside is your radius. Okay. And you need to know the height. So how tall is your cylinder? Once you have that information, you plug your numbers in and use your order of operations. Okay. Let's look at the pyramid. So for a pyramid, the formula they give is 1/2 P times S plus capital B. So P here is, again, the perimeter of the base. So when we're talking about a pyramid, we're talking about what side is it sitting on. So here, the square side would be my base. So I'd find the perimeter of the base times the S. So S is the slant height. So slant height means how high is this? So if I'm looking at this, how long is it from the base to the top along one of the sides? You see that? It's not talking about the height, which would be if I stuck my marker in there like that. It's talking about from the base to the point of the pyramid, but just along one of the sides. And then capital B is the area of the base. So that's for a pyramid. For a cone, we have pi r s plus pi r squared. So again, here you need to remember that the S is the slant height. The R is the radius. Okay. So for my cone, I'm going to find my radius, which is halfway across the circular part. The slant height is going to be, if I draw a line up the side here, how long is that line? And then here I'm using the radius again. The last formula that we're going to be using is for the sphere. And the surface area for the sphere is 4 pi r squared. So for the sphere, you simply need to know what the radius is. So the radius would be if I took the middle of it and took from the center of the circle to the outside. So I'm just using the radius here. So what I'd like you guys to do is spend some time with this formula sheet. I also have given you another formula sheet. The other formula sheet looks like this. You probably picked it up in class. And it just gives you other ways to look at each of the items. It breaks it down with a visual next to it. So I think this one's very nice because of that. So you might keep both of these out while you're working today. Okay, so what I'd like you to work on is in your salmon colored packet, you're going to be working on the next couple pages. And this is homework. I'd like you to have this done for next class on Monday. There's one page, page 8, that focuses on surface areas. So I would like you to do the surface areas. Please skip number 8. Okay, you can skip number 8. We're not going to focus on that detailed of a figure right now. And actually, you can skip number 3 as well. Focus on the other ones and see how you do. I will put the answer keys onto WAMAP for you so that you can check your work. Then you can work on the volume. Again, I'm going to cross off 2 of these. I'm going to cross off number 3 and number 4 that you do not have to do. And I just want you to find the volume of each of these figures. Okay. I do have one challenge assignment for you. challenge assignment is the handout that looks like this that you picked up. I'd like you to take a look at this. You're welcome to work with other people on it. I will take questions on this one on Monday, and we'll see how you do on it. You can skip number 6, okay? So do your best. You can skip number 6. Okay, thank you very much. That's the end of that video.